Okie dokie, Advent of Code, day 3. We have a series of banks, of battery banks. Going from left to right, we need to find the maximum number formed when you join exactly 2 digits. So for example, in this row it would be 98, in this row it would be 89, and in this row it would be 78. Oh, that's interesting, that changes my strategy a little bit. And then in this one, it would be 80. Well, it would be 91. And we have these examples here at 90. Yes, 92. Sorry. Cool. So we have a series of lines. I think part 1 needs to be. Well, first off, we need to find the maximum value in the line, and we need to find the first instance of it, because with the exception of this case here, the maximum value will always be the first digit, the tens digit. Now this case is a special case that we're going to have to think about, so it's worth thinking about now. If the maximum value is the last one, then you need to find the first instance of the value below it, and then you keep going down until you find the first instance. So for example, if this weren't a 7, if there were a 6 over here, you'd go through and you go, well, the max value is last, can't do that. I'm going to look for where a 7 is, there's no 7, I'm going to look for a 6, find it here, take that 6, and then you can store the max value and use it afterwards. So that is a bit of a special case, but otherwise that should be pretty easy. So line max voltage is going to take a line which is going to be already, we'll make it a vec of u size and return a u size. And so we're going to do line iter, and then we are going to, we need to know, first off, the thing I'm going to use needs to be reversed, because we're going to use the max function on iter, which gives you the last value of max. So if I want the first value, I need to reverse the iterator. And then I want to enumerate it because I want the location, and I actually want to do enumerate first. And then we're going to max by. Max by is going to take a closure, A and B, and tell us how to compare. So what we've got are 2 tuples of u sizes. I need to double check which way round enumerate goes. Enumerate returns I value, so we need to check by the second field, which is 1, and so it's A.1 CMP B.1. Okay, so just use the comparison of the values. That is going to that's tens, and we'll just unwrap it. Yeah, so that's, let's not call it the tens digit because it might not be yet, and let's call it max I and max val. Okay, so we can destructure our tuple straight away here. Great. Now we need to handle our let's handle our good path. If max I plus 1 is less than that, i.e. if this is not the last value, then what I want to do is return, let's assign it. Let's singles val, let digit, there we go, be equal to line from max I to the end, max I plus 1 to the end. Iter, and then I don't need to enumerate it, I don't need to reverse it, so I can just do the max. Done, right. And what we want to return is going to be max val times 10 plus digit. Cool. That bit is easy. Otherwise, max val is last. We need to search for, is there a remove? I know what we need to do. We need to, this is actually going to be much easier. What I want to do is I want to say let tens be equal to line iter filter on x, and we're going to say that x must be less than max val. Then we're going to take the max that remains and unwrap, and then we'll return tens times 10 plus max val. Okay, so this is going to go through and it's going to say, right, I found an 8, but it was the last value. I'll need to double check that logic for a second. So now, iterate through this again, remove 8s, and find me the next highest value. And that's going to be 7. 7 times 10 is 70 plus 8 will be 78. I don't need returns here because nothing else. Because I'm not going to do anything else. So this if block is going to be our return. So let's sort out references. Great. So now part 1 just needs to do input dot iter. In fact, we'll do input dot iter, and we're going to map it. We're going to parse. We'll take a line, which is a ref string, and I need to parse the string as okay. Line chars map 2 digits, and then we're going to collect that in a vec. By using an underscore here, by the way, I'm just letting Rust work it out itself. So it currently thinks this is going to be a U32, but it's not. That vector I am then going to send to line max joltage. Okay, and I want to return this whole value. So hopefully it will now decide that's going to be a U size. It will not. So I will explicitly type U. Oh, it won't, because to digit is going to return a U32 instead of a U size. As U size, please. You're not happy with that? Mismatch type expected a U size and got a map standard slice iter. Line chars map to digit unwrap collect. Let's just take line max joltage out of this for a second. Oh, okay, yeah, no, that's fine. It's just being unhelpful because I haven't yet done anything with the result, and then we need to sum that up and return that, and hopefully that passes the test. Great. I have already commented out day 2, so this shouldn't be too bad. It's panicked because of a not yet implemented, which I will need to get rid of. Otherwise I can't run this, which is in part 2. 17,142. Sweet. I don't know how I'd feel about... I mean, I guess we're only trying to make the escalator move, we're not trying to make the elevator move. I don't know how I feel about the elevator being powered by backup batteries. I guess the escalator you can always just walk. Although this is probably a magic elevator that needs power to transcend dimensions. Who knows? You need more joltage to overcome static friction. And hits the big red joltage limit override. You lose count the number of times she needs to confirm yes. Okay? I mean, this feels like a big safety thing, so that's probably fine. You need to turn on exactly 12, for fuck's sake. So, well, first off, let's grab the test. Oh, these are big. New test value is that when running part 2. Okay. So, the easy way is just to write this all again. The slightly... So now this trick of filtering isn't going to work, because if there are 2 of the maximum value... actually maybe it will work. Because if there are 2 of the maximum value, I'm going to get the... I am going to get the first one, because I reversed my iterator here. So once I've got the location of the first one, if it is not the last one, what I can do is, so this is going to be something like line max joltage n. It's going to take a line and a vec of use size and an n, which is a use size. That n is going to be target, actually. No, it can be n. So it's basically going to say find max, if not last one, pop off vec, reduce n by 1, recursively call function, and then it's going to say, so we need to make sure all the multiplications are correct. And do found max times 10 to the power n plus recursive call, and the recursive call itself will be doing that. And so if you start out with n is 12, and it might not need to be 12, it might need to be it'll need to be 11. Well, let's do the case we had before for part 1. If n is 2, then you find like a 7, remove that 7, call again with n equals 1. So this is going to be 3 digits. We need n equal 1. We need to start 1 lower than the number of digits we have. Find, say, so let's say it is this one here. We're going to find the 7. So actually the logic for finding the 7 is the same. I still need its location though. So then we find 8. N is 0, so we'll return. add 7 times 10 to the power of 1 plus 8 times 10 to the power of 0. Okay, cool. That recursive share would then go up to find maybe like there's another 7 or something, whatever. So actually, this logic is probably solid. And I can probably just modify this function in place. Let's call you n and make you a usize. So we're going to find the maximum value. And we know that the maximum value is not allowed to be at the end so long as n is greater than 0. So, the good case, the maximum value is not at the end. Don't need to do any checks here. And what I want to do is, so we're going to make a mute line. We're going to say, we've got a take function in vec, I believe, remove. So we're going to say, let digit is let val. So we're going to find the max and then we're going to remove it. It's going to be line remove max I, which is going to return an option. No, it's just going to return the type. Okay. Then what we want to do is let next be equal to line max joltage, line and n minus 1. And we need a guard in here to make sure that n doesn't just go on forever. If n is 0, return val. Else, do this bit. And return val times 10 to the power n plus next. Is this always going to work? What happens if we did have n is 2? So if n is 2, we would get like, let's say we have 973. So we would get 9 times 10 to the power of 2 plus 7 times 10 to the power 1 plus 3, I think, because we're not ever modifying the value we get back from our recursive call, which is just going to handle its own thing and then get another one. Okay, that's fine. So far that works, and the only issue is if we are in this else statement, and if we're in that else statement, we want to do exactly the same thing, but we also need the rev in here. So I need iter enumerate rev, filter on x, and we're going to say x.1 needs to be less than max value. So filter, if this is true, it will include the value. So we only want to include any of the values below. We want the max, and it's basically the same. I might need to reorder this. Is that. So then I want to do exactly the same logic, i.e. this bit. So I think, if n is 0, if n is 0, you've just got an early return, right? Let's deal with that to start with. If n 0, return max val, right? So that entire block disappears. take value, find the next, and return that. Cool. In this case, n is not going to be 0, and I want to do exactly the same thing again. And I'm okay with some duplication here, that's fine. Let val be equal to line remove max I. And it's still okay to call, it's not quite max I, it's, yeah. And actually, this is no longer true, this needs some fiddling, and I'll explain in a minute. Change this to be related to n. Let's just stick it to doing that. So that means we're definitely going to panic. What don't you like about max val? Expected, you set the fine. Do that. Remove it, and then let next be equal to the same thing. Line max voltage n minus 1. Return val times 10 to the n. Okay, cool. Now, what unreachable gives the to do? That's fine. So the issue is initially I get away with this if max I plus 1 is less than line nth, but actually what I need to check is it's going to be easiest to do this with this one. This one here. So if n is 12, I come all the way to the end, I go 9 is the last value. That's not great. I would need the 9 here. But actually, I don't need the 9 here. I need the 9, like, over here. I need there to be 12 digits in a row for me to do anything. So the first value I pick has to be, and we can use this. This value of 1, that was n. So I think this is just going to be a straight up, if u plus n are less than the line length, we're all good. So for example, in the sequence 9, 8, 7, 6, 5, 4, 3, 2, 1, where n is, let's say, 5, I want this to pick out, so we're going, if n is 5, we're going for a 6-digit number. So 1, 2, 3, 4, 5, 6. Yes, I probably should have been able to. Yes. I need this to be the other way around, don't I? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, so 4. Right, because the highest number we could get that's going to be 6 digits is going to be 4, 5, 6, 7, 8, 9. So we're going to find 9. Well, it's only going to be acceptable if let's put the positions above. So the length of this is 10. No, it's not the length of this is 9. I haven't got 0. The index of 4 is 3. I need 3 plus 5 is 8. 8 is strictly less than 9. So yes, this is fine. This works. And that to do can go away. We've got some red squiggly lines. Yeah, this can go away. And you need to do line max joltage. Where is the end of this function called? Here. With n is 1. Part 2 is part 1, but line max joltage where n is 11. Yes, you copy and paste errors. Again, excellent job, interview. Both sides now failing. So, I think this is going to need some offline debugging. I might cut this down. We're at 42 minutes, I'm definitely going to cut this down. Okay, right, a little bit of offline time because you didn't need to watch me debugging for 45 minutes, but I have succeeded. Fundamentally, this came down to the fact I was doing 10 to the power of n, except that this in Rust is not a power, this in Rust is a bitwise XOR. So it was giving incredibly funky results, and actually you need to do this power function. Annoyingly, even for a U size, this power function takes n as a U32. Not sure why, seems a bit of an odd choice, but there we are. There was also a slight bug in how I was doing indexing, and this is called next2 because I was concerned that there was some weird shadowing problem. However, there is not, because Rust is doing its sensible thing. So, right, so the way it works is you find the maximum value as per normal. If this is the last digit, just return straight away. Otherwise, if the maximum value, if there are enough values after the location of your maximum value to create the rest of the result, then recursively call this function, finding the rest of the result. So far, so good. And then return. It becomes this res function because it was easier to debug that way. But fundamentally, return your value times 10 to whatever power is required, plus the thing that came from the recursive call. If there are not enough digits, and you can probably, in fact, you can definitely skip this step. You could make this entire thing simpler by just shortening line up here anyway. So I'd be willing to bet that actually, if you index line here, if you index line here as line len minus n, I reckon you will never see this print line. Yeah. So actually what you need to do is just say, well, the only possible values I can take are the ones that leave enough space for the rest of the value. This entire logic can go away, and all I need to do is return. I don't even need this if statement, right? Because it's guaranteed now. And that's just the return value. And this still passes tests and provides the right result. So actually, that is much, much simpler even than the original function that I came up with. And just to prove it works, let's make part 1. I've got part 1n running, and it's passing tests. Let's just get rid of part 1n, give you max line voltage n with a value of 1, and we're looking for 17,142. I also made a slight optimization. Perfect, that works. This is taking a vec of U size, but when you index like this, you end up with a slice. Well, no, I started out with a slice because I wanted to be able to index like this. When you index like this, you need to add your reference back in. And suddenly, I don't have to do any of the split off or taking. I can just make my slice shorter and shorter and shorter and shorter. And that is much, much nicer. So the final code, then, I'm going to take off this n. Is it F2? And I'm just going to break something down in tests. Yeah, I don't need to test part 1n anymore. So the final code actually is super simple, and it's basically just this. It is Reduce your search size so that you are only searching in the vector where you definitely have numbers at the end. Add on the rest. Find the maximum value in that. Find the location of the maximum value as well. And then search this set down here and look for the maximum value within there and get shorter and shorter and shorter and shorter. And that's it. And now I need to go do some video editing for the first time in these streams. Well, I probably needed to do video editing before, I just didn't. That's day 3.